Hello. So let's start a new topic, which is the vector. Okay. See, what is the aim to study vector? The aim behind to study vector is a deep understanding of the principle of the mechanics. See, the subject of mechanics is the heart of physics, and to study mechanics, it is very essential to study vectors. The study of vector provides a good introduction to the role of the mathematics in physics. By using vector notation, physical laws can often be written in a compact and the similar form, as we can write down Newton's laws of motion, F is equal to ma. So here force and acceleration are the vector quantities, and it indicates that acceleration is in the direction of the force, and there are three components of this vector: x component, y component, and z component. Okay. See, our principal motivation for introducing vectors is to simplify the equations. Okay, so let's see how we can define vectors. Vector can be approached from 3 points of view. So one is the geometrical, second point of view is the analytical, and third method is the axiomatic. Okay, so although all 3 points of views are useful, we shall need only the geometric and analytical approaches, okay, in our discussion of the mechanics. Okay, axiomatic approach we mostly study in mathematics. Okay, so in a geometrical point of view, vector is denoted as an arrow. So it is a head and it is a tail, and in an analytical manner it is written as this: a or b vector, where the magnitude is the length. It is the magnitude of the vector, which is the length of the vector, and it shows the directional arrow. So vector is magnitude into the direction. A cap is direction. It is known as the unit vector. So unit vector we can write down as total vector upon magnitude. Okay, so it is a basic definition of the vector. So, and we will see about the algebra of the vectors. See, actually I didn't define vector till now. I just show you how we can show the vector. See, we will define vectors later on, because I don't want to give you any ambiguous kind of definition. Generally people say that, okay, if something has a magnitude and direction, it is vector. No, it's not necessary. Few quantities have a magnitude as well as a direction, but these quantities are not vector. Example, the current has a magnitude and direction, but it's not a vector quantity, it's a scalar quantity. Okay, and some people say that, okay, vectors should have magnitude, direction, and it should follow the vector algebra laws. Okay, it is a more correct. So laws are much necessary. So if a quantity is following the vector algebra laws, it can be treated as a vector. Okay, magnitude plus direction, and it should follow the vector algebra rule. It is a basic definition. This is another kind of the definition of the vector which we generally use in the tensor analysis, which is the higher course of the theory of mechanics or the classical physics. Okay, so we deal all these things later on. So it was our small introduction of the vectors. Okay, so we will continue our lecture in the next session.